Hello, and thanks so much for joining me on this tutorial and my final project overview for Amazon Web Services Sumerian application. So for my final project, I chose to build something in Amazon's 3D and VR rendering platform, Sumerian. To get there, you just go to the standard regular Amazon management console, and then you find Sumerian, and this is the landing page when you open up Sumerian. So I want to just kind of walk through what I did as a final. Here's the final project as it looks completed. The idea was to build a labyrinth, like that old game, right, with the wooden plates, and you move the wheels on the side, and the marble drops through. So just to kind of give an idea of what it's going to look like when we're done, kind of going through and talking about everything. This is what it is. So here is a unique URL that is unique to this experience. Like I said, Sumerian does virtual reality and 3D rendering. I don't have virtual reality equipment, so I wasn't able to actually jump into the VR space. But you in theory would be able to put on some gear and appear to grab this with the remotes and tilt yourself. So some pretty neat stuff. So this is a pretty basic application as far as functionality goes. But you click the start button and your ball drops, and you kind of just roll on your way. Now, it's interesting. You notice the ball is rolling really fast. All right. This is actually very strange. Well, not to say strange so much it is infrequent. The physics engine on Sumerian is one of its biggest downfalls. It's a problem because it's not very what's the word? It's not very reliable. As in, it sometimes it works really great and sometimes it doesn't. So right now, what we're seeing is the ball is too heavy. For whatever reason, the physics engine is attributing too much weight to the ball right now, and so it's dropping really, really fast. Most of the time, it won't drop this fast. In fact, let me refresh the page here and let's see if we'll get a different result. Let's see here. Yeah, see, look, boom. You refresh the page, you get a completely. I mean, this is a completely different setup, and you'll notice right now that the ball is bouncing a lot. The bounce setting on this ball is 0, so it shouldn't bounce at all. However, due to the limited capacity of the physics engine on Amazon Sumerian, it can't. It's not doing a very good job. So Amazon. So in summary, as far as just kind of an overview, the Sumerian does a really good job with a lot of different features. It's got some great features, but as far as being a powerful, reliable physics engine, I don't think it's very close to being something that will be, usable for a while. You can see how much the ball is bouncing right here. I mean, that's crazy how much it's bouncing, and it shouldn't be bouncing at all. In fact, I had to increase. If you notice, actually, I had to. Well, you can't see, but the wall's right here. But I made the physical barrier probably 5 times higher, just because this bounced ball would kept going over walls and whatnot. Also, you may recall that the actual board game had holes in it that the ball could fall into. When I went to design these holes, I ran into some issues where the functionality that is very much built into this application wasn't working properly. So I actually had to jump on the horn with Amazon Web Services engineers in the Sumerian development department. And I was chatting with them, and they basically said that because my project has so many objects in it, you'll notice, I mean, each of these walls had to be built individually, right? The board is a different object, the buttons are different, the ball is different. So this is probably about 40 objects in here, which frankly, I don't think is a lot for a virtual reality space. I mean, imagine if you were designing like a building, right? I mean, you'd have thousands of objects. Well, what happens is the objects work fine, but when I start trying to attribute triggers to them, all of a sudden, the triggers won't work. So for example, when I roll up to the end here, what should happen, and actually have that all written out and should work, is I should pop onto this trigger, boom, and the ball disappeared. So this time, interestingly enough, it worked, and I could hit start again, the ball drops and it goes. I'd say 8 out of 10 times that doesn't work, and because of that, let's try to refresh the page. We'll see if we can't get it. Let's see if we'll do a follow up again. Let's see what kind of physics we'll get this time. And because of that, when I went to design the holes through which the ball would, in theory fall, right, they wouldn't work. The ball would roll over them. And let's see, hold on, I don't want to have to just sit here and watch me play this game, but basically it would just roll over and nothing would happen. So I sent the full project, all my files. I sent it all to AWS, and they went over it, and they're like, "Yeah, there's nothing we can do about it." They said that they're actually looking to change their physics engine because they've had so many complaints about it. And if you actually open up the Slack page that Sumerian is on, you can see that there's actually a whole bunch of they have a whole bunch of issues with it. So it's a little embarrassing, but at the end of the day, like, I think it's pretty new as everything is in the VR space, and I have very little doubt that Amazon's going to get it fixed, and it'll soon become a very robust and a legitimate option for professional rendering on the cloud. So that being said, that's kind of the high level overview, some of the problems that I ran into, but I want to show you get into the nuts and bolts of this thing and kind of break down what it took to build and all that. So let's pop over to the Sumerian console. We're going to go ahead and start a new scene. We're just going to take my demo for the name. So it opens up to this empty world, okay? And there's this empty space that's going to load up, and this isn't a floor. This is just a grid for reference, and it continues off to infinity, and you have these lights here that are there by default. But otherwise, yeah, it's just an open, empty space. So one of the first things that we have to do when designing really any platform, more than likely, I would imagine, is build out a floor. So that was the first thing that we did. Before I get into the actual building, I want to just do a quick overview of what all this stuff is. All right, on the upper left here, we have the entity panel, and this is where all the objects live. So when I come in here and I create a disk, which is going to turn into my floor, I see the disk object came up. And then over here on the right, this is the details tab that describes all of the information about each of the objects. So I'm going to go ahead and rename it ground, because as we get into a bunch of objects, we're going to want to make sure we know which ones we're talking about. So here's my disk. Notice it does not look like the ground. It's not even oriented like the ground. So we come over here, we select ground over here, and we come over to the transform, right? And so here's our rotation. So we'll flop it over. Oh, so the ways you can scroll this, click and drag to move this. You can type in a value if you want it precise. I mean, we know we want it to be a 90-degree turn, so we want it like that. Alternatively, click and drag, 270, whatever, however you wanted it to work. So here is. Here we go here, 90 degrees. And you can use these arrows to move it up and down to change the position, right, where its location on the actual map. So this functionality exists, obviously, for all of the objects. But the scale here, our transform, our scale object is based in meters, or so they say. So we're going to increase this to 100 meters. We're building a small game board, so the ground in theory should appear as if it's going off to infinity. And when building a small game board, 100 meters will be good enough for infinity, I think. So here we are on the ground here, but it still doesn't look like a ground, right? It still kind of just looks like an empty blank disk, which is exactly what it is. So what we do is we can add texture and color to it. So here are some, when I think of the labyrinth sort of game, I think of a rocky sort of texture. So what we're going to do is I'm going to click and drag from this other screen over here, just a texture. Okay, boom, and now we're texturized. Now we're really close, right? So you can kind of see that it starts getting granular because this is not a high-resolution photo. I tried to find some, but I really didn't want to buy one off of Shutterstock or whatever it's called online. So anyway, so here we have, this is kind of just our background detail. And, when we come onto the project, this is what it looks like. Well, it's pretty good, I think. So there we are. That's our ground. You can adjust the colors. If you pop in here, you can do some, make it look like Mars or whatever, but we're just going to leave that blank and kind of hang out with that. All right, so now we've got to create the game board. And again, it's the same functionality as everything else. Excuse me, the same way we're going to, all the objects are going to be built the same way, right? So here we are, we create a cube. Notice that so we're hanging out at the center of the universe here. So if you notice, we're right in the middle there. So we need to, obviously, the game board is not going to be a cube. So what we're going to do is we're going to do a couple things. We're going to float it up. Probably just float it up. 2 meters, I think is fine. Maybe 5. We want to keep it even numbers, actually, because in a second here we'll be placing the walls. And if we want to make the walls precise, in my opinion, it's easier to work with even numbers when dividing and that sort of thing. So that's just what we're going to do. Using the wheel click, I can pivot like this. Right click lets me rotate around the object, and the scroll wheel gets me in and out. So here we are with this. We want to transform it, right, so it looks more like a box. So again, we're going to do a 4 by 4 by 1. We're going to rotate this guy, again, 90 degrees. And actually, we're going to make this 0.4. There we go. That's nice. It's a thinner box. Okay, so here is our game board. Again, a game board's about 4 meters wide, and that's fine. So now we have a game board, but honestly, it doesn't really look like a game board, right? It just looks like a white block. So let's fix that. Again, we're gonna click and drag. I had got some light pine material from Home Depot, so that's looking a lot better. And that's it. There's our game board. All right. So we've built that object. Now we need to start. Oh, excuse me. Let's go ahead and start. Let's do a board here. Call this the game board. Okay. And now let's build our first wall. Okay. So we've got to build one wall, and then what we're going to do, we'll duplicate for the rest. So let's pop this guy up here first. We'll get to the exact measurements in a second. Basically, I know the width of the board, right? If I come here, width is 4. So I know I want this to be 4. But I don't actually want it to be as thick as the board. So we're probably going to go 0.2 and again 0.2. Okay, so 0.2 by 0.2. And now we want to place it. All right, so I know center of mass is at 4, right? So if I click here, I see the center of mass is floating up at 4 meters. So I got to add half of this center of mass and half of that. This is 0.2 and that is 0.4, so I need to add 0.3. So I need this to float at 4.3. Okay, and now we were sitting directly on top of the board, which is, again, why I wanted to use even numbers. I think it's a little bit easier. So now x-axis, we wanted to shift over a little bit. Excuse me, the z-axis, we wanted to shift. Again, the game board is 4 meters wide, so we wanted to shift over 2, less the center of mass for this guy. So we wanted to shift over 1.9. Okay, that'll push us right over to the edge here. And again, we want this to look like pine, so we're gonna come over here to the color and texture. We're gonna pop this over here. Now, this one, if you pivot up top, excuse me, the grain in this case is against it, but when you build this wall over here, the grain will be with it, and it actually gets kind of tough to see. So what we'll do is we'll just darken this up just a little bit more. Darken there. There we go. See, now it's nice. And if you scroll in, you can really see this grain. I think it's pretty neat how that functionality and how well that works. Okay, so we pop into there. So now we've got the wall. So now really what we need to do is we need to add some physics now to it. Right now, let me go ahead and create the marble. That way, this will really do a good job at showing what I'm talking about with the physics. Okay, so here's the marble. Okay, it's a big marble. So let's make this a little bit smaller. Geometry. Let's rename the sphere a marble. Okay. Transform. Let's probably make it 1.1. A little small. Let's make it 0.3. I think 0.3 would be okay. I had to use some when we had problems with the physics engine. One of the problems actually when designing the physics engine is you can't have objects that aren't in perfect aren't the 1-to-1 ratio. Yeah, look at that. That's a good size ball. So come over here, we can kind of rotate and we kind of see that. Yeah, that's going to be a good height. So if you don't have this as 1, 1, 1, 1, the physics will stop working for interacting objects. It's really strange. I tell you, there's some really bizarre limitations on this physics engine. Again, that was confirmed with the Amazon engineers. That's one of their workarounds is make the ratio of things you want to interact 1, 1, 1, and then scale everything else. So in my project, the ratios are much different because I had to make this ball as big as it was originally. So the game board in my scenario is actually, a factor of 10 larger technically, but relatively speaking, it's the same size, right? Now, if I, so let's watch this. Let's watch this scenario play out a little bit. Okay, so I'm going to lift this ball up so it's off the board. Okay, so now we can see we got some space in there. If I hit play, what happens? Okay, now we're simulating the real scene. And it's just floating there. Nothing's happening. Why? Because I haven't assigned any physics to it. So what we have to do is we gotta attach some components to this object. And the first one we're gonna do is a rigid body. Rigid body, when the rigid body component is attached to an object, it makes that object react to gravity. So I can change the mass. That mass is what I was talking about earlier. If I make this mass 1,000, it's gonna drop a lot faster, right? But if I make it 1, it's gonna drop at its presumably standard rate. You can add velocity to start and stop with it, a drag, or you can say, hey, don't move on the X or Y, don't rotate on the X or Y. A lot of different things you can do. None of this we really needed to do because we wanted the ball to just roll naturally. Okay, so now that that's applied, notice all the changes save automatically. That's another really cool feature. So this, boop, it just drops below the floor, drops below everything, because by default, these objects can coexist in the same space. So what we need to do to all of these objects is we need to add what's called a collider. This collider says, hey, I need you guys to interact as if you were solid objects. Now the default is a box. Obviously the sphere is not a box, so we want to change that shape to sphere. And then there we have it. We are sitting at a sphere shape. The yellow, okay, you can see that yellow box around there? That is, and I'll actually move it for you. That's the actual physical interaction, all right? So for example, if I do this, scroll out and hit play, oh shoot, we gotta add it to the board real too. So let's go ahead and come here, add collider. Now we hit play. What's gonna happen is, of course, during the demo, that doesn't work. So when, in fact, so here's, we got the box selected. Let's see if we can, so yeah, everything should be working properly. This happens not infrequently. I can't even tell you the number of times I've had to sit here, hit the refresh button. This is what Amazon says to do, is to hit the refresh button, and it kind of, well, there you have it. It is not functioning by design as designed. Well, we are going to continue on and pop this guy back down to 0.5 and let's save and try one more time. Okay, that didn't work. So let me actually come to the transform. Excuse me. Yeah, come to the transform for the ball. Let's see if we see anything different. See, that's exactly what I was talking about. Now when it's 1, 1, 1, all of a sudden it works. So I was having it's a big problem. It's a big thing that Amazon needs to fix, and they're working on it. So anyway, so there's our massive ball, right? So that's why I had to scale up the table in my actual project. So that, for the purposes of this, it doesn't really matter. We're not actually going to build the board. So what I would do from here, right, is you would add a collider again to the wall. And now that the collider is added to the wall, now you would just replicate this wall and then hand place each of them. So I'm going to pop over to my project in the console, and here it is. Okay, I have hidden the ball. The marble is right there. Look how it looks normal, right? But if you look at the size of the game board, it's let's see, the game board is 3 meters, right? And the marble is 1. See, so that is how it ended up being. So I hid this because I wanted the ball to be hidden at start, right? Just like if we come here, we refresh the page, the ball is going to be hidden when we start the game. Okay, so you have to hit start to make it show up. Now, let's talk about the functionality. This is the really cool part that I think with Sumerian. So you come down here, the assets panel. This is where you get stuff to start interacting. Now, Sumerian can do a lot of things. It can create animation. It can create, like I said, virtual scenes. You can create games. You can do all sorts of neat stuff with this. Simulate environments. I mean, there's just so much cool stuff you can do. Now, I only tapped into this, what's called behaviors and scripts. Okay, behaviors is kind of the simple version of a little programming algorithm that we attach to an object. Now, to attach a behavior, and again, what a behavior does is it says, hey, do certain things when certain things happen. Okay, very generic. When you want to get into some really specific stuff, you open the scripts, and we'll get to that in just a minute. So under the behaviors, what you do is you come over here, you open up the state machine. Well, excuse me, you add a component. You're not going to see it here because I've already added it, but under here it'll say state machine. And state machine basically says, hey, object over here, be ready to accept instruction from these behaviors. Okay, so I come over here and I add, I've added a behavior called generate ball. I'm going to go over and edit. I'm going to kind of explain and walk through this behavior. And actually, I'm going to actually walk through a more simple behavior, the start game behavior. I've associated that with the start key. So whenever someone clicks, right, on click, so this is linked, I'll go over here and see what is it linked to. This is linked to the start object, and the start object is right here. And just real quick, just to briefly mention, you see all these objects are nested inside one parent object. I did that so that they are treated as one object. So I attach a state machine to this game board, and I say, hey, this parent object tilt, all of these items will tilt with it. If I didn't establish that, then these walls wouldn't tilt at the same time. Okay, they need to have just that wooden underpiece tilt, and the walls would stay in place in 3D space. But when you nest them all together, they start getting treated like one object. And you can make changes to them. You can move them. You can do a number of things. Okay. And then there's an offset for the rotation, kind of a troubleshooting thing that I had to kind of re-nest everything into this one. Again, that's a workaround because you can't actually, if you notice, if you look at the game board, okay, you see how the center of mass is down there for the actual game board? That's no good. We don't want that because then when it rotates, it's going to rotate in a big arc around this center. So what I did was I put it inside of another object to bring the center of rotation up to where it should be. And again, that's a workaround that Amazon has suggested because it doesn't, you can't shift the center of rotation, the axis, I guess, in any other way, which is, again, in my opinion, very strange. So that's that. So back to behavior. So we have this behavior start game. So what's going to happen is this is linked to the that start object. So on click, and we know on click of what? Well, on click to the item that it's linked with, start. So on click of that start object, do something. Come over here and emit. Emit is you come over here, you add action, and you can find, you search emit. And emit tells you this is the action that it's going to do. What does emit do? It sends a message to the channel. So all these other behaviors are on the same channel, and they're listening. Well, they can be listening if you tell them to, but this is going to emit this to this whole channel here, where all these behaviors will hear. Now, again, whether they're listening or not is a different story, but they would be able to hear this message that's being emitted. Okay, because I need to send a signal. Okay, to the rest of the behaviors that, hey, the game started. Do something. Okay, and then after that behavior happens, the color changes. I want the color of the start key to change, just so that the user knows that, hey, it actually worked. I clicked it, I did the right thing, so something should happen. So if the ball didn't drop for whatever reason, then we'd know that it's an issue with the ball, not an issue with the start trigger. Okay, so that's this behavior. Now, like I said, it's listening, and so if we come over here, the first thing that happens with the generate ball behaviors, it says, hey, listen, wait for someone to say start. It doesn't know who's going to say it, but it knows someone on this channel, some behavior on this channel is going to say start. And when it says start, come over here and place the ball. And here's the starting position of the ball, some other, these angular velocity things. These really don't, you can start the ball with velocity if you wanted to, but there's no need to. And then I change it to show. Right now it's hidden, like you can see over here, but then we change it to show. So it's actually showing, you can actually see the ball, and then it transitions to the next event. And this is waiting for the end. This end event is actually linked to the end button, okay, which you saw earlier works some of the time. This trigger would have been used whenever the ball hit one of the black holes. We would just use the same trigger. We would associate this trigger with each hole, so that every time the ball hit a hole object, it would emit an end message to the whole channel, and that would have hidden the ball. Okay, so this is what happens whenever this channel hears the word. So actually, this one actually should be end right here. Here's the word end. This thing will go through, right? Okay. So, excuse me. That's actually, I had that right. The generate ball is listening for end. Once end happens, it's going to submit to a script. Okay, so this is the basic behavior of events, right? They can interact, they can collide. You add these actions. Actions are the actions are each of these are an action that's added to a state. These behaviors are actually also called states. Hence the term state machine, right? It's the machine for all the states, right? That are being implemented. States are composed of actions, and actions are added here. There's a handful of them. There's actually, I mean, again, Sumerian's relatively new, so there's actually not a ton, but there's a bunch, right? You can see the stuff with lighting and hosting and special effects and the camera collision attribute, all that sort of stuff. Now, what's really neat, and I thought was really cool, and I really wanted to implement, but I couldn't implement it because the scripts need to be implemented through a trigger, and all of this stuff is implemented by trigger. So let me show you what I mean by trigger. So if I come to this finish, end game trigger. So there's this other object right here. The object is sitting right on top of the finish triangle. So there's a triangle, and this end game trigger. This is a little circle. You can't see it, but it's there. And I have the collider option open. And it says trigger. So what this is saying, hey Sumerian, whenever something hits this, do something. Okay, do an action. All right. So when I reach endpoint, this is not waiting for a click. It's waiting for a trigger. It's saying, hey, wait for something to happen. Once you hear a trigger event triggered from the game, do something. Well, emit an end. When you emit end, what I want you to do is I want you to generate this ball, or excuse me, I want the ball, which is just sitting here listening under the generate ball behavior. It's just sitting here listening for the word end. When end happens, come over here, and this is the score. Okay, so this expression, this script right here is going to update what would have been a score panel right in here to display the user score. So here's the script for the score panel, which I used. They had a demo that I used to learn all this, and this score script, the bones for it came from that. I modified it a little bit to meet my needs, but there's a scoreboard here that has some that would show and has some see it's HTML based, and then the script you can write. Basically this would just you can put in some crazy functionality in here that's pretty neat. Now the API for this is very light, so there's not a lot of help there. But there's that script, and that script would allow for lots of updates and whatnot. So anyway, in summary, and that's all I did for this project. So in summary, it was a really awesome project and really fun to work on. Really glad I had the opportunity to jump into it and take a look and get this thing to work. I still think it's pretty cool. It's kind of a bummer that the see, there we go. We're back to super speed. It's kind of a bummer, I think, that the objects didn't work. Let's see, is it going to work for us today? Oh, working. How about that? It's kind of a bummer that it didn't work for to actually get it to work like I wanted it to. Again, Amazon said that was their system error. So thanks so much for listening to my video. I know it's a little bit longer than 10 minutes, but there's so much to talk about, and I really enjoyed learning it. So I just wanted to kind of share. So anyway, thanks so much for listening, and I really appreciate it.